So today we're going to cover section 3 from chapter 1. Today we're going to learn the midpoint and the distance formulas. You are going to need to memorize these two formulas for the quiz on Thursday. So this will be the last lesson that we're going to cover before Thursday's quiz. Tomorrow we will review and get you ready for that very first quiz of the school year. So the first thing we're going to do is define what a midpoint is. And a midpoint is a point that divides the segment into two congruent segments. Now, remember that in geometry this year, we can never assume anything. So for example, if I were to draw a segment and label it with an A and a B, and let's say I put C right smack dab here in the middle, I cannot assume that C is a midpoint without them giving me numbers. For example, JM has a length of 3, and so does MK. So if they have labeled the two individual little segments with numbers, and if those numbers are the same, then you can conclude that M is the midpoint. Another way that you can tell that a point is the midpoint by congruency marks. So if I were to have given you that AC was congruent to CB by adding in those little congruency marks, then you could conclude that C is the midpoint. But without numbers or without markings, just because C looks like it's in the middle, you can't assume it's the midpoint. If M in this picture here is the midpoint, then you can tell that JM is equal to MK. So if you don't get any markings on your segment or any numbers, as long as they give you this statement that M is the midpoint, then you can conclude that those two pieces have the same size. You can either say that they're equal or that they're congruent. Now, coming up, later on in the chapter, we're gonna talk about angles. The only thing that you can ever assume is something is when it's a straight line. If I draw something like that, you can assume that that's a straight line, and we're gonna also describe this as a straight angle, and it's got 180 degrees. Other than that, you can never assume anything else. You're gonna have to go by the information that's given, the congruency marks, or if it's labeled with how long something is. Pretty good? All right, let's now define what a segment bisector is. And a segment bisector is basically going to be either a point line or a ray or a line segment or a plane that's going to split a segment into two equal pieces. So it's going to intersect that segment at its midpoint. So the point could bisect the segment, a ray could bisect it, a line segment, or a plane. These are all bisectors, but they cannot be bisected themselves. So what I mean by that is these 5 things that I just underlined. All of these things can take a line segment and they can split it and bisect it or hit it at its midpoint. So for example, if I label this as AB, and if I put point M here, M could be a segment bisector, and M would be the midpoint. I could also bisect that segment with a ray. It doesn't have to slice through it. I could also add in an arrow and say a point here, and let's call it C. This would be a bisector, and I could say that ray MC bisects AB. I can never bisect a line because a line goes forever. I could never find the middle of a line. I could never find the middle of a ray. I could never find the middle of a plane. So a line, a ray, and a plane can never be bisected, but they can be bisectors. So for example, in the picture here, notice the green CD is a line. It's bisecting the segment AB because it's splitting segment AB into two equal parts. So remember, when something has been bisected, you're splitting that segment into two parts that are now going to be equal. So as soon as they tell you that you have a segment bisector, know that the two sides on either side of that bisector are now going to be equal parts. So here I could state that AM is going to be congruent to MB, or you could also say that it's equal to MB. So when I use the equal sign, I'm talking about like an exact measure. Like I could say that these are both 5 and 5. When I'm talking about using the congruent symbol, all I'm worried about is I know they're the same size. I don't care if they measure 5 inches or 10 inches. All I care about is that they're exactly the same size. Yes?
How would they be the same size if they have different distance?
They have to have the same. So whenever something's bisected, that thing that's going to bisect them, in this case it's this line. This line is splitting this segment from A to B into two pieces that are now equal. Does that make sense?
Yes, well, I have like congruent. You said it could be 5 and 10, but still be congruent?
No, it would have to be 5 and 5 and 10 and 10. But like, let's say if I had a segment and I said it's bisected here, A, M, B, and let's say I put a 5 here, then I have to have a 5 here. Or let's say I made it a little bit longer. I guess what I was talking about is this could be 10, but then this one has to be 10. They have to have the same on both sides of that bisector. Does that make sense?
Yeah.
Okay. So I didn't care what it was. That's what I was trying to say, that I don't care if that first picture they're both 5s or if it's the second picture and they're both 10s. All I care about is that they're the same size. So let's try an application of this with our first example. So here, example 1, this is a skateboard design. And again, in words, they're telling me that VW bisects XY at point T. So here is VW, and it's bisecting this line here, or this segment XY. Now, they were nice enough, and I know it's hard to see, but it's got little red congruency marks. So that should have been a clue as well, that T is going to be that midpoint of XY. So soon as I saw that that was bisected, that tells me that this piece over here from X to T is going to be equal to T to Y. In the problem, they told me how big it was for XT. X to T right here is 39.9. And because it has the congruency marks, I also know that from W to Y, it's also 39.9. So because it wants me to find the length of the whole thing, all I have to do is add 39.9 to 39.9, and that'll give me the length of the entire thing. And this gives me 79.8, and it was labeled or told me in the problem that these are centimeters, so 79.8 centimeters. So if you got a word problem like this on your quiz, this is all you would have to do. If you'd rather just do 39.9 times 2, you could do that as well. Again, we're not using calculators, so you need to be able to add decimals. Question?
If
Let's go ahead and double check it. So let me do the problem again. 39.9, 39.9. So 9 plus 9 is 18. Carry the 1. And then 9 and 9, 18 plus 1 is 19. And then carry the 1, 79. Good? Okay. Now, just to give you a little preview of how this problem might be a proof, I'll show you what's going to start to come. So if this is just a word problem, they ask you to find x, y, this is all you would have to do. But if they ask you to justify what you're doing, this is how sort of the proofs are going to start to be set up. So the first thing you would do in your proof is you're going to state what's given. And you would state that point T is the midpoint of xy. And because, and this you would, over here you have to give a reason why you could say that, and you could say that it's given. Or you could have also said that VW bisects at point T. So because of this, we know that xt is equal to ty. And then they also told us that xt equaled 39.9. And again, this was still given, the 39.9 equaled the ty. And then from there, I could demonstrate my segment bisector. They wanted me to find xy, so I'm going to show that by adding xt to ty, I can get the answer to the question. And my reason I would be using the segment addition postulate. This is where I write my abbreviation. Then the next I would show a substitution, and I'm going to substitute what xt and ty equal, which is 39.9. Now you will not have to do something like this on your quiz. This is coming at the end of the chapter. And this reason would be a substitution. Then the next thing I would do would be add. And I get 79.8, and that reason is add. And then you can finally conclude that the length, which was the question, the length of xy is 79.8 centimeters. So what we're going to learn how to do is we're going to have a column of statements and then a column of reasons why we made that statement. And then we'll separate it with like a little line here. So this is coming. This is just a rough little demonstration of what you're going to be seeing coming up at the end of the chapter. So example 2. So they gave us the statement that point M is the midpoint of VW. Now, also in the picture, notice they already added in the congruency marks. But just remember, if they didn't have these little red marks, just by them stating that M was the midpoint, that tells me that VM is going to be equal to MW. And this is how I'm going to find the length of VM by setting these two expressions equal to each other. So I'm going to put VM is equal to MW, and I can do this because they had the congruency marks as well as they told me that it was the midpoint. Now I'm going to substitute in the expression for VM, which is 4x minus 1. Substitute in the expression for MW, 3x plus 3. And now I have to use my Algebra 1 skills. I need to move my variables to one side and my numbers to the other side of the equal sign. Now, it doesn't matter if you move letters first or numbers first. I'm choosing to move my letters together first, and I'm going to move them to the left. Again, you could move them to the right. It's totally up to you. So I'm going to subtract 3x from both sides, because I need to get my letters on this left side. So then now I'm left with x minus 1 equals 3. I now need to move the numbers together. So I'm going to add 1 to the other side. And my final answer here is x equals 4. Now, throughout the year in geometry, be very, very careful of what the question is asking you to do. This question did not ask me to find the value of x. It asked me to find the length of VM. So now that I found x, now I'm going to go back and I'm going to take the expression for VM, which is this 4x minus 1, and now I'm going to substitute my value of x that I just found into that expression. I'm going to do 4 times 4 minus 1. 4 times 4 is 16 minus 1. So the length of VM is going to be 15. Now, keep in mind that throughout the day, let's say this was a quiz question. I can change up this quiz question within the classroom and throughout the day. Maybe my C period had a different question than you, just by changing these little letters here. And instead, maybe the question will say, find the length of VW. So all the given would have been the same. The only difference was if it were asking for VW, you need to remember that both sides, VM and MW, were both 15. So VW would be 30. So be very careful if you happen to talk to your friends who maybe take this test first period and you have it second, and they're going to say, oh, they ask you to find the little piece. But then maybe when you get your quiz might ask you for the whole thing. So be very careful when you're taking your testing quizzes throughout the year that you read precisely what they're asking for. Because again, I change it up by just changing a letter or changing one little number. The picture may look the same, but it definitely is going to be something different. So just be careful. Everybody good on this slide? All right, now we're going to learn the midpoint formula. You need to memorize this formula for the quiz on Thursday. So basically what we're doing when we're given two coordinates or two ordered pairs to find a midpoint is it's the average of the x coordinates and it's an average of the y coordinates. And that will give us the coordinate for our midpoint. And this is the formula right over here. This, after we add the x's and divide by 2, that will give me the x of the midpoint. And then once I add the y's and divide by 2, that'll give me the y of my midpoint. Now, notice these little 1s and 2s here. All these little 1s and 2s are like labels. So notice order pair A in this picture, or this endpoint A. Let me do this in blue. I could say that this is going to be my order pair number 1. And then the B up there, notice it's got little 2s at the bottom. I could say that that's just going to be my order pair number 2 because it's got the little subscripts of a 2. So these little 1s and 2s at the bottom of the x and the y, they're just labels. So, and then those are going to be the numbers that you substitute into the formula. Remember, whenever we use this formula, our answer is going to be an ordered pair. So you need to memorize this for Thursday. And let's try an application of it. So I'm going to go ahead and rewrite that formula up at the top of the page. So we're going to get x1 plus x2. We're just going to take the x's, add them, and divide by 2. Take the y's, add them, divide by 2. After I do that, this one right here is going to give me my x of my midpoint. And once I add and divide by 2, this is going to give me the y of my midpoint order pair. And that's what that little m represents, that it's the midpoint. Now, on the quiz on Thursday, the question that you're going to get is going to only be in words. I will not be giving you a picture of the segment graphed. Because technically, if you're given a graph like that, you can just look to see what the order pair is for the midpoint. So this is why it's just going to be given to you in words, and you're going to have to show me how you use the formula. Now, when I'm given the 2 endpoints, I need to label point R as either order pair number 1 or order pair number 2. It doesn't matter. So I'm going to say point R is going to be my x1 and my y1. So this will be x1, y1. And then point S, I'm going to say this one's the x2, y2, order pair number 2. So now I'm just going to take it and I'm going to plug it in. So I'm going to take x1 and x2, so 1 plus 4, divide by 2. And then I'm going to take the y's, y1, y2, add them, divide by 2. I'm going to add 1 plus 4, I get 5. Negative 3 plus 2 is negative 1. This is my midpoint. Now, you can leave it improper, and you can leave it as the 5/2. However, if you were expected to graph it, I would recommend that you convert 5/2 to a mixed number or a decimal. So be able to recognize, especially if you get this question on an SAT or a PSAT, they may have changed this to 2.5, comma, 1/2, or made it a mixed number, 2.5. I would accept any form of that 5/2. You can leave it the improper, you could make it a decimal, mixed number. You could even have changed the -1/2 and made it -0.5. Again, I would have just left it like this and not tried to do anything else to it. Because again, remember your quiz is free response, so you can leave it either way. Let's try another example where this time you're going to be given an endpoint and the midpoint, and you have to find the other endpoint. So this is where we're going to use the same formula, but we have to modify it a little bit or work backwards from it. Pretty good on this slide? All right, this one. I'm going to write the formula at the top. We have x1 plus x2 divide by 2, y1 plus y2 divide by 2. And remember, this gives me the x of the midpoint. This one gives me the y of the midpoint. So what I'm going to be doing is setting this equal to the x of the midpoint and then take the y's and set them. So I'm going to make 2 equations here out of this formula. So I'm going to do, for the x coordinates, I'm going to do x1 I'm going to do x1 plus x2 divide by 2 equals xm. Then the y's, y1 plus y2 divide by 2 equals the y of the midpoint. Now again, let's label our given. So notice they told me that the midpoint of JK is point M. So this point is going to be my XM, YM. The endpoint, J, could either be the X, it could be order pair 1 or 2, it doesn't matter. So I'm just going to say this is order pair number 1, so X1, Y1. My missing endpoint K, I'm looking for X2, Y2. That's what I'm solving for. So let's plug it in. So X1 is 1. I don't know x2, and x of the midpoint is that point 2 at the top. Now I need to solve this, and you had something similar to this in the homework last night. So the first thing you want to do is get rid of the denominator. So I'm going to multiply both sides by 2 to get rid of this denominator. And now I'm left with solving 1 plus x sub 2 equals 4. Subtract 1, and x sub 2, or the x of my point k, is going to be positive 3. I'm now going to do the same thing to get the y of that endpoint. Going to plug in y sub 1 from point j, which is 4. I don't know y sub 2. That's going to be the y of my k. And then the midpoint up there, the y of that midpoint is 1. This is a y. So now the first thing again I'm going to do is get rid of the 2 in the bottom of the fraction by multiplying both sides by 2. I'm keeping my equation balanced. This causes it to cancel out of the denominator. And now I'm left with 4 plus y sub 2 equals 2. I subtract the 4. And the y of point k is going to be negative 2. So my new endpoint, point k, is the ordered pair 3, negative 2. The next slide here has the distance formula. You need to memorize this formula for the quiz. Okay? You're going to need to memorize it because we will use it occasionally throughout the school year. Again, your endpoints of this segment that you're trying to find the length of are going to be your x1, y1, your x2, y2, just like with the midpoint. Now, when your lines are horizontal, like the blue line in that triangle, or if they're vertical like the red, we could just count the little squares in the graph. But when the line is diagonal, like this one that's pictured here, we need to now use the distance formula to find the length from A to B. We can't count squares. Now, in your pre-algebra class, or even in your Algebra 1 class, they might have also taught you Pythagorean theorem. That's another way to find the length of AB. But we're not going to cover that now. That will come later on. For now, we're just going to use the distance formula. And again, you're going to memorize that. So let's go ahead and go to the last slide, and let's do 2 examples using the distance formula. So again, let me write the distance formula up at the top. It's x2 minus x1. This time we're subtracting the x's, subtracting the y's, and then after we do the subtraction, we're going to square that difference, add the 2 differences, and square root it. So again, label your 2 endpoints. And again, it doesn't matter. So I'm going to call this one x1, y1, and this one x2, y2. Going to plug it in. So I'm going to be doing 7 minus 13 squared plus 10 minus 2 squared, and it's all under the square root. I need to follow order of operations. So I'm going to do the parentheses first. 7 minus 13 is negative 6. 10 minus 2 is 8. I'm now going to square. This becomes 36. This becomes 64. I'm now going to add. And now I have to square root. So the distance from A to B is the square root of 100, which is 10. We're not using calculators, so you should know your perfect squares up to 20. You probably know your perfect squares up to 12 because you learned times tables in 3rd grade. So then it's just a matter of going beyond that. If you don't know them, you'll just practice them. Let's try one more example. Same thing, x1, y1, x2, y2. Subtract them. 4 minus 2 squared plus -1 minus 3 squared under the radical. 2 squared plus -4 squared. 4 plus 16. Square root of 20. 20 is not a perfect square. We need to leave this in simplest radical form because we're not using a calculator. So what we need to do, all right, so now when you're simplifying this, we can't leave a non-perfect square not broken down. If we can break it down, we need to. So the way that you will simplify a non-perfect square is we do a factor tree. I can break it down into 4 times 5. If you realize 4 is a perfect square, you square root it, and then this would be your answer. If you decided to start with 2 times 10, then when you break down this, you would have to keep going until your radicals are all prime numbers. So now that I broke it all the way down to prime, now I go back and look for pairs. Because when you make a pair, this turns into a perfect square. You take the 2 out of the radical, and then you leave anything that doesn't pair up underneath. And notice it's the same answer I got there as well. I'm going to do a few more examples for you of simplifying radicals because throughout the year we're not using calculators and you will have to leave all of your answers in simplest radical form. Next I'm going to add a page and I'm going to do a few more breakdowns of radicals just to show you a few more examples. So for example, let's say I asked you to break down the square root of 75. I could break that down into 25 times 3. Whenever I see 75, I think about 3/4. And again, if you're good at breaking down and you realize that one of your factors is a perfect square, you could just square root it and leave the non-perfect square behind. If you didn't realize that, then the other method is to break it all the way down until you get prime numbers. So 5, I'm going to still factor. And now all of my factors are prime numbers. Now what I do is I go back and I look for pairs. Once I can make a pair of a radical by its same radical, that turns into a perfect square, and then it just comes out of the radical as the number that's underneath. And then you leave anything that doesn't have a pair back under the radical. Another one we could do would be 98. I could break this into 49 times 2. Now, if you realize 49 is a perfect square, square root it and leave the 2 underneath. If you didn't, then what you could do is keep breaking it down. 7 and 7. Leave the 2 underneath. Make a pair, comes out, and leave it underneath. We will be doing this all throughout the entire school year because we will not be using our calculators. We will always leave our answers in simplest radical form. So this is where we have to go back and do a factor tree of the number and then look for pairs. If there were more than one pair left behind, then you would multiply everything that comes out. So for example, 48. If I were to break this down, say 6 times 8, neither of these are perfect squares, so I'm going to keep going.
I still haven't hit prime numbers, so I would still have to break the 4 down. So the 2's prime, the 3's prime, this 2 is prime, but 4 would become 2 and 2. I now look for pairs. I have a pair of 2's here, a 2 comes out. I can pair up these 2, another 2 comes out, but this 3, he's left behind, nothing to pair with, so he stays underneath. Everything that came out of the radical, if there's more than one number, you'll multiply it together and then leave whatever's behind. If there were more than one numbers left under the radical that didn't pair, you would also multiply those as well. So we'll practice this again tomorrow. Again, if you end up doing the distance formula and you get a square root answer that's not a perfect square and you're not sure how to break it down, at least show that work, how you got there, so you don't lose all of the credit. So that is it for section 1.3.